Hi everyone, welcome to this short video on motion in a plane. This is a key concept in physics that helps us understand how objects move in two dimensions, like a football flying through the air or a satellite orbiting the Earth. Let's get started. When we talk about motion in a plane, we mean movement that happens in two directions, usually along a flat surface. This is different from straight line or one-dimensional motion. In two-dimensional motion, we describe the object's position using both x horizontal and y vertical axes. Real-life examples include a car taking a turn, a bird flying, or a thrown ball. To describe this motion accurately, we use vectors, which tells us both magnitude and directions. Next, when we come to the vectors in two dimensions, in two-dimensional motion, three main vector quantities are used. Position vector, which tells us where the object is. That is, r bar is equal to xi bar plus yj bar. Displacement is the change in position where vector over time. Velocity vector, which shows how fast and which direction the object is moving. V equal to differentiation of r bar divided by d dt. Acceleration is the rate of change of velocity, where a bar is equal to dv bar divided by dt. Each of these components along the x and y axis that must be analyzed separately. All of these have components in the x and y directions, which we often analyze separately. When we come to the projectile motion, now let's focus on very common type of motion in a plane, that is projectile motion. Projectile is any object that is thrown or projected into the air and moves under the influence of gravity alone. The key idea here is the horizontal motion is at constant speed. The vertical motion is under constant acceleration due to gravity. This combination results in a curved parabolic path. Some of the equations of projectile motion. Suppose you throw an object with some initial speed at an angle. We break that velocity into two components. Here are some of the equations that you should look after. Some of horizontal motion, vertical motion, time of flight, maximum height, and range. These equations help us predict how high and how far the projectile will go and how long it will stay in the air. When we come to the next topic, uniform circular motion. Another interesting example of motion in a plane is uniform circular motion, where an object moves in a circle at constant speed. Even though the speed doesn't change, the direction of the motion keeps changing, which means the object is accelerating. This accelerating is called centripetal acceleration, and it always points toward the center of the axis, where A equal to v square divided by r, where nu is speed of the object and r is radius of the circle. Example, satellite orbits, car turning in a circular track, rotating fan blades. You see, this is satellite orbiting Earth or a car making a turn on a circular track. This is uniform circular motion. This is one of the best example for uniform circular motion. Then we come to some of the real life applications of motion in a plane. Understand motion in a plane has a lot of practical uses. In sports, players use projectile motions to calculate how to kick or throw. Engineers design roads and rides considering circular motion. Space scientists use these concepts to launch and control satellites. Even amusement park rides are based on these motion principles. Let's let's recap quickly. Motion in a plane involves two-dimensional motions and a vector analysis. Projectile motion shows how horizontal and vertical motions work independently. Circular motion involves constant speed with changing direction. These concepts are not just theoretically, they help us understand and design the world around us. Thank you.